Unit 2, Section 5. Symmetric relations. Section objectives. By the end of this session, the students will be able to determine whether or not a relation is symmetric. Symmetric relations. A relation R on a set A is symmetric if A relates to B implies B relates to A. In other words, A RB implies B RA for all A, B belongs to A. For example, suppose R is a relation defined on a set of integers Z by A is related to B if AB is greater or equal to 0. Then, to show that R is symmetric, let us assume that for AB belongs to Z, A is related to B, that is ARB. Then AB is greater or equal to 0. But since multiplication of integers is commutative, we have that AB is equal to BA. Thus, AB is equal to BA is greater or equal to 0, implies that B is related to A. Hence, A is related to B implies B is related to A, showing that the relation is symmetric. Symmetric relations. Example 1. Define a relation R on Z as X is related to Y if and only if X squared is equal to Y squared. Prove that the relation R is symmetric. Solution. Suppose that AB belongs to Z such that A is related to B. Then A squared is equal to B squared implies B squared is equal to A squared implies B is related to A. Therefore, A is related to B implies B is related to A. And so, R is symmetric. Symmetric relations. Example 2. Define a relation R on Z as X is related to Y if and only if X squared plus Y squared is even. Prove that the relation R is symmetric. Solution. Suppose that XY belongs to Z such that X is related to Y. Then X squared plus Y squared is even. But X squared plus Y squared is equal to Y squared plus X squared. And so Y squared plus X squared is even, since X squared plus Y squared is even. This implies that Y is related to X. Hence, X is related to Y implies Y is related to X. And so, the relation is symmetric. Symmetric relations. Example 3. Define the relation R on the set S equals R cross R by AB is related to XY if and only if Y minus B is equal to X minus A. Show that the relation is symmetric. Solution. Suppose that A, B, X, Y belongs to S such that AB is related to XY. This implies that Y minus B is equal to X minus A. That is equation 1. When we factor out -1 from both sides of the equation 1, we obtain -1 multiplying B minus Y, which equals -1 multiplying A minus X. That's dividing both sides of the above equation by -1. We obtain b minus y is equal to a minus x. Hence, xy is related to ab. Therefore, the relation is symmetric.